This is for Year 11 Methods. It comes out of Chapter 1 Review, and it's question number 25. Using a CAS, sketch the graphs of y equals 2 minus x, and I've got that equation here, and I've rewritten it as minus x plus 2. X plus y minus 5 equals 0, which is the same as y equals minus x plus 5. The third one is 3y equals 2x plus 3, and if I move the 3 over, y equals 2/3 x plus 1. And the last one is 3y minus 2x minus 7 equals 0. That's 3y equals 2x plus 7, therefore y equals 2/3 x plus 7/3. Now I've got to use a CAS to sketch it. Okay, so over here I'm going to write y equals minus x plus 2. And I've got x plus y minus 5 equals 0. And I've got 3y equals 2x plus 3. And I've got 3y minus 2x minus 7 equals 0. I'll execute that. I'm going to bring up a window. I'm going to go, I'm going to go Window View, Memory, Initial. Okay. And I take the first one and I graph it. Take the second one and I graph it. Take the third one and I graph it. And I take the fourth one and I graph it. And show the equations represented the sides. Okay, so I've sketched the 4 graphs. To show that so in part A, show that the equations represent the sides of the parallelogram. Parallelogram has 4 sides, and this is a parallelogram, it's got 4 sides. For it to be a parallelogram, the opposite sides have to be parallel. And I know that for parallel, they have to have the same gradient. And the gradient of this is m equals -1, and the gradient of this is m equals -1. The gradient of this line is m equals 2/3, and the gradient of this line is m equals 2/3. Since these two sides have the same gradient, they're parallel, and these two lines have the same gradient, they're also parallel. So I'm shown that it's a parallelogram because 2 sets of the lines have the same gradient. Find the coordinates of the vertices of the parallelogram. Okay, over here, analysis, G-sol, intersect between this one, enter, and that one, no, not that one, move it to that one, enter. So that's going to be 0.6 and 1.4. Okay, back over here, analysis, G-sol, intersect between that one, enter, and move to that one, enter, and that's -0.2 and 2.2. Individually writing. come back over to my calculator, interactive analysis, G-cell intersection. I've done the 2 with that line, so now I move it to that line, enter, that line, enter, there's the intersection point at 2.4 and 2.6. And lastly, come back to the graph, analysis, G-solve, intersect, move to that line, enter, move to that line, enter, and there's the intersection point at 1.6 and 3.4. So that's part B. Find the coordinates of the vertices of the parallelogram. Find the lengths of the sides of the parallelogram. Now, how do I find lengths of sides? Okay, part C says find the length of the sides of the parallelogram. So here is my parallelogram. The length of the side from A to B, that length there is the same as that length there. And the coordinates of A is this, and the coordinates of B is this. And my distance formula tells me that it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So here we are. The square root of x2 will be 1.6. x1 is negative 0.2. And y2 will be 3.4. And y1 will be 2.2. So it's going to be the exact length of AB. And AD will be this to this, so 0.6 minus negative 0.2 squared, and y2 is 1.4 minus 2.2 squared, which gives me that distance for the lengths of the sides of the parallelogram. Find the equations of the diagonals. Okay, the diagonal AC goes from point A to point C, and this is the coordinate of point A, and this is the coordinate of point C, and this is the rule that I'm going to use for the 2-point rule, which is y minus y1 equals y2 minus y1 over x2 minus x1 bracket x minus x1. So, starting over here, I'm going to have y minus 2.2 equals fraction on top, y2, which will be 2.6, minus y1, which is 2.2, over x2, which is 2.4, minus x1, which is minus 0.2, bracket, and inside the bracket, x minus x1, which is negative 0.2. And press execute, and that gives me an equation that if I put into a new line and I solve for y, will give it to me in the form of y equals, and there it is. So y equals 2x on 13 plus 29 on 13. If you multiply everything by 13, that gives you 13y equals 2x plus 29, and in general form, 2x minus 13y plus 29 equals 0 is in general form, and there it is in gradient y-intercept form. And that's for AC. And to do the other, which is BC, or B to D. And for B to D, here it would be y minus 3.4, since that's the y coordinate of B, equals 1.4, the D coordinate, minus 3.4, over 0.6 minus 1.6, all brackets, and then press execute. That gives me that expression. Put that in a new line, solve it for y, advanced solve y. That makes it y equals, and there's the equation in terms of y equals, if you want to put that into general form, multiply everything by 5, and then from that, yeah, that's what the equation is.